Good morning, my friends. I'm Clover, and this is Genuinely Approachable Sudoku. And first of all, I'm really sorry about the audio today. I know exactly how messed up it is. This was the best I could do today. I am in my basement today, right next to the whole HVAC system, and my friend is upstairs drilling holes in my floor at the moment. There was really no other way I could find to do this, so if you want a video, it's gonna be this one with this audio. I apologize. Anyways, today we're solving Yours Truly by Philip Newman. This is a celebration for February 22nd, and it is a difference and ratio pairs Sudoku. That means we have normal Sudoku rules, so we're placing the digits 1 through 9, once each in each row, each column, and each outline 3x3 region. And in addition to that, we have some black dots and some white dots in the grid. And wherever you see a black dot, the digits surrounding it are in a 1-to-2 ratio. In other words, one of them is twice as big as the other. And wherever you see a white dot with a little 2 in it, the digits around them have a difference of 2. So one of them is 2 greater or 2 lower than the other. And we're going to start with these runs of 4 cells that are all separated by black dots because there is only one way to do 4 consecutive doublings or halvings in Sudoku, and that is to have those digits be 1, 2, 4, 8. So we're going to go either left to right or right to left. And I'm going to leave that for now because if we go down here, we see that this orientation is not possible, 1, 2, 4, 8 going from right to left because of the 2 in the bottom right region. So we have to be going like this. And that tells us that we have a 2 dot next to the 1, so that makes these 3, 5, 7, 9, and then our last digit here is going to be a 6. This run of cells that are separated by white dots, because they each skip a digit each time you go from one to the next, they are all going to have the same parity. In other words, they're all going to be even or they're all going to be odd. However, there should only be 4 even digits in each row, and we've already used one of them. We've already used this 2 here. Therefore, these cannot possibly be all even. They must be all odd. So these are the digits 1, 3, 5, 7, 9 in some subset and combination. However, these guys cannot be 1 or 3. So these have to be from 5, 7, 9. 9 can't be in the middle because it would have to be between 2 7s. So we know that we're here in some combination. One of those has to be a 7 because it has to be either 5, 7 or 5, 9. Now, this guy cannot be a 5 because we would be going 5, 7, 9, and then question mark. So we know we're increasing from right to left. That's a 1 or 3, that's a 3 or 5, 5 or 7, 7 or 9. Okay, now if we look over here, we don't have anything down here that's going to immediately help us resolve these digits, but if we look at this string of 2 white difference dots, if this was an 8, we would have to go 6 and then 4, but then we would have 2 4s in the row. So that can't possibly be an 8. That must be a 1 going to 3 and then 5. And then the 1, 2, 4, 8 is oriented like this. And the 3 that I just placed is going to resolve this string of digits here. My last 3 digits in this row are 6, 7, and 9. And they're 6, 7, and 9 can't possibly be on a black dot because there's no other digit in Sudoku that's double or half either of those. This must be a 6, and then half of 6 is 3. This can't be a 9 because there's a 9 in the column already, so that's a 7, and then this over here is a 9. We need a digit that is 2 different from 3. That's going to be either 1 or 5. Now, if we look here, we need a run of 3 digits that are all halved or doubled, and we have an 8 in the column already. So the only way we can actually still do that is 1, 2, 4. 2, 4, 8 includes an 8 in it, and then 3, 6, 12 ends with a 12, which is going to be too big. So this has to be 1, 2, 4. We don't know which way around it goes yet, but we will soon. And then this pair is either a 1 and a 2, a 4 and a 2, or a 4 and an 8. So that digit's going to be either 2 or 8. Okay, now let's look at some of the boxes that are starting to fill up a bit. So we need 1, 5, 6, and, or not 6 and 9, 7 and 9 in this region. That can't be a 5, and that can't be a 9. Oh, it's not 7 and 9. We need a 1, 5, 4, and 9. I'm a little tired this morning, I'm sorry. And that can't be a 9. Those can't be 5s. This can't be a 1. If this guy was a 1, then we would go 1, 3, 5, and we would have 2 3s in the row. If this was a 4, we would be going 4, 6, 8, and if it was a 9, we'd be going 9, 7, 5. And both of those appear to be fine for now, but we're going to resolve them by looking at these cells down here. So these are going to be 4, 5, 6, 8. Those can't be 4s because there is already a 4 in the column. And now we're looking for 2 digits that are 2 apart from each other. 5 isn't 2 apart from any of those digits, so those have got to be some combo of 4, 6, and 8. And because only 4, 6, and 6, 8 work, we know that there has to be a 6 there. This can't be a 5 because there's a 5 in the row, so that's an 8, making this 6 and 4 and placing our 5 right here. And now that 6 tells us this is a 7, so that puts us in the 9, 7, 5 universe. 8 is 2 away from 6 and 6 only. This has to be a 1, 4 pair to finish off this row. And then these guys are going to be 2, 3, and 8. That's not a 3, that's not an 8, and that's not a 2. Unfortunately, either of the combinations here still work, 1 and 2, 4 and 8, or even 4 and 2, so we don't know which of those universes we're in just yet. These cells have to contain 1, 7, and 9. I'll clean that up just a touch. Now 4 is 2 away from 2 and 6, and because there's already a 2 in the column, we're going to place a 6 there, which makes the digit next to it a 3. These guys are going to be 3, 6, 8, and 9. We have a 3 right in that column already. We have a 9 in the row. 6 and 9 and 8 and 9 don't have a difference of 2. This has to be 6 and 8, making this a 3 and 9 in that order. Now we only have 3 digits left in column 4, so let's pencil them in. They're going to be 1, 2, and 5. The only 2 digits out of those that have a ratio of 1 to 2 are 1 and 2. Then these are going to be 4, 7, 8, and 9. And I can make some eliminations just based on what digits I already have. These have to now be 7 and 9 in order to have a difference of 2. I've placed a 4 in this cell by Sudoku. This has to be in a ratio of 1 to 2 with 4. It can't be an 8, therefore it's a 2, which resolves this. These digits are now going to be 6, 8, and 4 to finish this row, and that's not a 4, so there's my 4. These are from 6, 7, and 8. And I have an 8 in this column, so that's a 6, 7, 8, 6, and 8, and that's resolved. That's not a 7, so these are 1, 9 pair to finish off this column. We have either a 2 or a 3 here. If this was a 3, the digit above it would have to be a 6, but because there's already a 6 in that row, we know that must be a 2, which is paired with either a 1 or 4. That makes this an 8. And now we know that can't be a 1 either. That's a cute little 1, 4 pair here. We need a 3 and a 7 to finish off the column. And then to finish this row, we need 1, 2, and 6. This already has a 2 and 6, so that's a naked 1. And that's going to be a 6 and a 2. These cells must contain 3, 5, 6, and 7. That can't be 6, that can't be 6, so there's our 6. And 3 and 5, and that takes care of that. This 2 here resolves this. In these cells, we need a 5 and a 9 to finish off this row, and that's taken care of, and that bounces back and resolves this. And finally, we need a 1 and an 8 to finish off. And that is how you solve Philip Newman's Yours Truly classic Philip pun title. I hope you guys got a kick out of that. If you want to try it yourself, the link to do so is in the description of this video, and I will see you again in 3 days.